In this video, I will be going to discuss how to work with embedding, and I will also discuss the concept of vector search. So first I will start what is a vector. A vector is simply a list of numbers. For example, if I need to describe a point in 2D space, so I will create x-axis and y-axis, and let's say I want to represent this particular point. So let's say this is 1 and this is also 1. So I can write 1 comma 1. So you can represent this point as a vector. Maybe you have another point here. Let's say this is 2 and 2. So 2 comma 2 is another vector. Similarly, you can create 3D vector if you want to define a point in 3D space and so on. So vector is simply a list of numbers which is representing something. It can represent point or many other things. But when I talk about embedding, so embedding is a special kind of vector which represents semantic meaning of text. So you see, you will have a text. Let's say this is a text. I will capture its semantic meaning and convert it into embedding. Embedding is a special kind of vector, right? It is a special kind of vector. So I will convert this text into numbers. Now you will be thinking, what is semantic meaning? So semantic meaning means that we are capturing the real meaning of the text, regardless of the exact words used. For example, suppose if I tell you what is the last stop of the train, or if I say what is the destination of this train, both are same. Either I use last stop or I use the destination, both mean the same. So the embeddings of these sentences will be very close to each other in vector space. So they are semantically similar. If I ask about the last stop or if I ask about the destination of this train, so both are semantically similar. So in embeddings, what we do, we take a text, we get the semantic meaning or the real meaning of this text and convert that real meaning into the vector or embeddings. And this we can do using the models which are known as embedding models. So there are many companies which are providing these kind of embedding models. So one of the company is OpenAI. So OpenAI has many models using which I can convert my text into embeddings, or you can say high dimensional vectors, because embeddings are special case of vectors. Then there are so many embedding models available in HuggingFace which you can also use to convert the text into embeddings. So up to now what I have told you, let me help you in revising. Vector are just the numbers which can represent anything, but the special vectors are embeddings. Embeddings are also vector, but they are special. Why they are special? Because they capture the semantic meaning of the text. Semantic meaning means it's a real meaning of the text, and convert it into vector or numbers, right? Here you can define how many numbers you want to have. Suppose you want a vector of a dimension called 512 dimension. Suppose you give this, then what will happen? The semantic meaning of this text, suppose this is a text, the semantic meaning of this text will be captured in 512 numbers. So there will be number 1, number 2, number 3 till number 512. So in those numbers the semantic meaning of this text will be captured. Suppose you want more better results, then you can increase this number. So for example, the default model of OpenAI uses 1536 dimension. Means Whatever the text you pass to it, it will convert the text into 1536 numbers. Now, these embeddings or these numbers are stored in vector store or vector database. There is a difference between vector store and vector database, but you can consider it like that these numbers are stored in special databases, which are either called vector store or vector databases. The examples of these kind of databases are FIES, ChromaDB, Pinecone, etc. So I will discuss the difference between vector store and vector database, but you can understand these are like databases which can store the embeddings. So now you have understood what is the meaning of embedding. They are special vectors which are storing the semantic meaning, fine, and it is storing the semantic meaning in numbers, or you can say embedding, and these embeddings are stored in a database which are either called vector store or vector databases, and these are the example of this. But what is a use case of it? Why I am doing it? So now I will be going to explain you the use case of embeddings. So these embeddings can solve semantic search problems. Let's say I have a document and that document have lot of FAQs and their answers. So for example, this is a question how to reset password and this is the answer of that. How to track my order, this is the question and this is the answer of that. What is a refund policy? This is the answer. How to contact customer support? So this is the answer. And how to update my shipping address? This is the answer. And there can be so many answers like that. So I have a document related to that. And what I will do, I will convert each and every question and answer into an embedding. For example, I will create the embedding 1 for this, embedding 2 for this, embedding 3 for this, embedding 4 for this, and so on. Then these embeddings will be stored in a database which is either called vector store or vector DB. Once it is stored in the vector store or vector DB, then you see I can ask the question. Suppose these are the questions which I ask. For example, I forgot my password. How do I log in again? Now this question is matching with this particular section of the document and it has the answer. So I need to extract this answer when I ask this question. So for that, what I have to do, I will convert this question in embedding also. And there are already embeddings available in the database. So let's say I am creating the embeddings or vectors of 512 dimension. Right now I have 5 embeddings here. So let's say these 5 embeddings are created and I am defining these 5 embeddings in 512 dimension space. So this is embedding number 1, let's say. This is embedding number 2. This is embedding number 3. And this is embedding number 4. And this is embedding number 5. So these are some embeddings I have created. Now this is the question I have asked. For this question also one embedding will be generated. Let's say embedding Q1. So what will happen? Embedding Q1 will be created somewhere here, suppose. Now what this vector database or vector store will do, this vector database or vector store can use cosine similarity feature. What do you mean by cosine similarity? In cosine similarity, it will try to find out the angle. If you see the distance between this vector and this vector is very close to each other, right? But this angle and this angle is very far, then embedding 2 is more far, then embedding 5 is very far, and so on. So what is the nearest vector to EQ1, the nearest vector to EQ1 is E1. This is called cosine similarity. So this vector database and vector store can use this cosine similarity feature to find out what is the nearest vector to it. So once you find the nearest vector, it means these vector and these vector both are semantically similar. So when I will ask this particular question, this particular section will match with this and I can find out the answer. Similarly, in the second question, where I can see the status of my order delivery. So here, this embedding 2 seems to be related to the order. So when I will generate the embedding for question number 2, so it will be somewhere here. Embedding of question number 2. And the distance between E2 and EQ2 is very near. So for this question, this particular text will be matched and I can extract the answer. In the same way, if I ask, can I return the product after 20 days? So this particular refund policy will be matched and I can extract the answer of it. So this particular vector EQ3 will be very near to E3. So the distance between EQ3 and E3 will be very less as compared to other vectors which are present in the database. This is one of the situations where I can use the embeddings. Now I want to clarify one more thing. Embeddings are generated by models. These models are provided by OpenAI or HuggingFace. This I have already told you. But this similarity search feature, it is used by vector database or vector store. That is why I am not using relational database. Why? Because relational databases like Oracle, SQL Server does not have these kind of semantic search feature. So this semantic search feature is used by these kind of databases like vector store or vector databases, which can compare the embeddings. Let me tell you more situations where this concept can be used. For example, legal or medical document search. There is a doctor or lawyer, it has lot of cases or reports and that doctor wants to find out the relevant document based on his keywords. So in those cases it can be done. It can be used in the e-commerce product recommendation. For example, the search of a user is comfortable running shoes for marathon training. So you see, system needs to find out the similar shoes, not just for running shoes, but also it is helpful for marathon practices. So those kind of recommendation it should give. So it should not be based on the exact keyword. It should give the similar products by understanding the real meaning of it. Then in resume matching also, for example, the job post is saying that we are looking for Python engineer who are doing ETL jobs or having the ETL experience. So actually in ETL we create the pipelines, but the person in the resume didn't mention ETL keyword, he has mentioned pipeline keyword. So this particular question can shortlist this particular resume. Once we capture the semantic meaning, so these kind of searches are easier to do. So these are some of the use cases where we can use the embedding concept and vector store concept. Later, I will also tell you that these embeddings will be used in RAG-based applications. So this I will also explain you in my future videos.